Students, welcome to another lecture of pharmacology, and in today's lecture we will be discussing agonist and antagonist. So let's start. So coming to the basic definition of agonist and agonist is a chemical that binds to a receptor and activates the receptor, therefore increasing its biological response, right? And on the other hand, an antagonist blocks the action of the agonist, while an inverse agonist causes an action opposite to that of the agonist. Now this is an image depicting the action of agonist and antagonist. Before any drug combines, the receptor site is empty and normal cellular activity occurs, right? In the second column, it shows an agonist drug. So when an agonist drug binds to the receptor site, cellular activity occurs, because agonists are drug substances or molecules which enhance the activity, right? Then when an antagonist drug combines, there is no cellular activity, meaning that the cellular activity is blocked when an antagonist attaches to the receptor site. So antagonists are also termed as synergism. So syn means together and ergon means work. So they basically work together. Now when the action of one drug is increased by the other, then that particular thing is termed as synergistic. In a synergistic pair, both the drugs can have action in the same direction, or given alone, one may be inactive but still enhances the action of the other drug when they work together, right? And then synergism can also be further divided. It can be either additive or supra additive. Talking about additive, in additive what happens, the effect of two drugs is in the same direction and it simply adds up. For example, the effect of drug A plus B is equal to the effect of drug A plus the effect of drug B. For example, when you give aspirin and paracetamol together, so they work as an analgesic or antipyretic, and their work is additive in nature. They enhance the effect of the two drugs in the same direction. The second type is your supra additive. Now in this particular thing, what happens, the effect of the combination is greater than the individual effect of the drugs. For example, the effect of drug A plus B will be greater than the effect of drug A plus the effect of drug B. When these drugs are given alone, then the effect will be less as compared to when they are given together. For example, when levodopa and carbidopa are given together, they have a supra additive effect. So talking about antagonism, so when one drug decreases or finishes the action of another, then that is termed as antagonist. For example, when the effect of drug A plus B is less than the effect of drug A plus the effect of drug B, then this particular phenomena is termed as antagonism. Usually in an antagonist pair, one drug is inactive as such but decreases the effect of the other drug, right? So antagonism can also be further classified into different types. It can be classified into physical antagonism, chemical antagonism, functional antagonism and receptor antagonism. So firstly, we will be discussing about the physical antagonism. Talking about physical antagonism, it is mainly based on the physical property of the drug. For example, charcoal absorbs alkaloid and can prevent their absorption. This is mainly used in alkaloidal poisoning. So this is an example of physical antagonism. Now coming to chemical antagonism. As the name suggests, the two drugs react chemically and form an inactive product, inhibiting their action. For example, KMNO4 oxidizes alkaloids, and this particular phenomena is used for the gastric lavage and poisoning. Now the third type of antagonism is your functional or physiological antagonism. So when two drugs act on different receptor or by different mechanism but have opposite effect on the same physiological function, then this particular thing is termed as functional antagonism, and they have a pharmacological effect in opposite direction, right? For example, when histamine and adrenaline are given together, They have an effect on bronchial muscle and blood pressure in opposite direction. And your last is your receptor antagonism. So in this what happens, one drug blocks the receptor action of the other drug. This is a very important mechanism of drug action because physiological signal molecules act through their receptor and blockage of which can produce specific and often profound pharmacological effect. Then your receptor antagonism can be further divided into competitive antagonism and non-competitive antagonism. In competitive antagonism, what happens? The antagonist is chemically similar to the agonist and it henceforth it competes for getting a place with the receptor and binds to the same site as the agonist binds to, right? So they have the same shape, they are chemically similar, so they have to compete to get a position in the receptor. And on the other hand, in non-competitive antagonism, what happens? The antagonist is chemically non-similar to the agonist and it binds to a different site which is termed as a allosteric site, which basically what? Alters the receptors in such a way that it is unable to combine with the agonist. So thank you so much dear students. This was all in today's lecture. If you have any queries, any doubt in today's lecture, please feel free to reach out to me. Thank you.